This video covers Trig P.1 notes. We're going to talk about real numbers and their properties. So we're going to first go over some vocabulary terms about different types of numbers. We'll deal with graphing numbers on a number line and graphing inequalities. We'll also talk in this video about absolute value and using that to solve some equations, as well as then finally dealing with solving equations by using order of operations and dealing with adding, subtracting, multiplying, and dividing fractions. So a lot of different topics kind of combined into this one section at the beginning of Trig. A lot of what we're going to talk today about is a review from your algebra classes, but it's going to be important that you get these characteristics down. You know how to add, subtract, multiply, divide fractions, solve equations, graph number lines, because we will be doing that throughout the course of the year. So let's first talk about different types of numbers. You've got natural numbers, whole numbers, integers, real numbers, rational numbers, and irrational numbers. If we start with natural numbers, those are the numbers that start at 1 and increase in the positive direction and no decimals. So if I was to start listing them out, it'd be 1, 2, 3, 4, and so on. Whole numbers are very similar to natural numbers in the case that there's no decimals, but it starts at 0 and then goes up. So the way that I remember this is the difference between natural and whole numbers is you notice that the word whole has an O in the middle there, and 0 looks a whole lot like an O, so I remember whole has an O there, 0, so that means this has to start with 0. Integers, no fractions or decimals. So those are both positive and negative numbers, but no fractions, no decimals. So maybe something like -3, -2, -1, 0, 1, 2, and 3. And of course, this would continue off in both directions, positive and negative. Real numbers are any number that you can think of. So it can be a fraction, it can be a negative number, it can be a decimal. If you can think of a number, it is categorized as a real number. So I might be able to say 0.3333333 and so on. That's a real number. 1/3 is a real number. Pi is a real number. Any number you can think of is a real number. Rational numbers, on the other hand, rational numbers, let's talk now about the difference between rational and irrational numbers. Rational numbers are any number that you can think of that can be made into a fraction. So in other words, if you have a decimal that terminates or repeats itself. So if we go back to this example right here, if we say, 0.3 repeated, that actually is a rational number because I can change that to a fraction as 1/3. If I want to talk about an irrational number, that is a number that it cannot be made into a fraction. So for example, the square root of 11. If I take a look at the square root of 11, I'm not going to be able to change that into a fraction or a non-repeating decimal, non-terminating decimal either, because the calculator is going to give me 3.31662479, and it keeps going on and on. Another example of an irrational number is pi. Pi is an irrational number. We tend to think of it as just 3.14, but there are a lot more digits to pi than just 3.14. So if you can change your number to a fraction, then you know that it's rational. If you cannot change it to a fraction, then it has to be irrational. Let's talk next about graphing numbers on the number line. So if I'm going to ask you to graph an inequality, I want you to tell me all of the answers that would work for this. X is greater than or equal to -3. Notice how I'm reading this. X is greater than or equal to -3. And then this way would be X is less than 5. So always start with the X and read it this way. So left and then read it starting at the X to the right. So if I asked you to graph this on the number line, you have to pay attention to whether it can be equal to -3 and whether it cannot be equal to 5. So at -3, since it can be equal to, we put a closed circle. And make it be very obviously a closed circle. And at 5, since it cannot be equal to 5, you want to put an open circle. Again, make it very obvious that it is an open circle here. So when you see less than or equal to, or you see greater than or equal to, it's going to be a closed circle. If you don't see that line underneath, so if you just see a less than or a greater than, that's when it's an open circle. And now figure out what numbers work. Those numbers that are less than 5, so that would be, I'm going to draw some lines above the graph, would be all of those numbers. But those numbers that are greater than 3 would be all of these numbers. Now that is not my answer. That is work to help me figure out where I need to shade. So if you're going to draw these lines, put them above the number line or below, but not on the number line. Because now you need to shade in everything where it works for both, and that's in between this. So you'd shade all of this in to say that it's all the numbers in between 5 and -3, but also including -3. Sometimes this is called inequality notation, but sometimes you're going to see the same type of concept written in what's called interval notation, and this is the way that the trig book will tend to write it. Understand that what this means is that the values you're looking for have to be between -2 and 2. A parenthesis means not equal to, a bracket means equal to. So understand that this means not equal to, whereas a bracket means equal to. So now if I'm going to graph these on the number line, at -2 I'm going to put an open circle because it's not equal to, that's what the parenthesis means. At +2 I'm going to put a closed circle. I'm going to make it very obvious that it's colored in. And I want the values that are then in between here. So in between, again, if I think about it, if I read this as x is less than 2, that'd be all of those. But more than -2 would be all of those. We'd shade the middle. Next one says w is at least 1. So w has to be greater than or equal to 1. And at most 5. So that means w has to be less than or equal to 5. It can't be bigger than 5. So let's graph these. W has to be greater than or equal to 1. So at 1 I put a closed circle. Greater than would be everything here. At most would be less than or equal to 5. So closed circle again here. And everything that is less than would be that. So we would shade that in. If I wanted you to write this in interval notation, the way that you would write it is, because both of them are equal to, you would use 2 brackets. Start off with the smaller number, go to the bigger number. So this is the way it would look like in interval notation. And this is the way that it would look like in inequality notation. The next thing we need to discuss is the idea of bounded versus unbounded. So if something is unbounded, it means that it's going off into either positive infinity, like this one, or maybe negative infinity, like our next example that we can't quite see yet. But if it's bounded, it means that it has 2 stopping points. It has a stopping point here and a stopping point here. Same thing for this example. This is bounded because it has 2 stopping points. The graph doesn't continue off on one side or in one direction. So when we're dealing with doing an unbounded one, the number that we need to put on our number line is -3. I've got to ask myself if this should be an open or closed circle. This is a bracket so that it means that it's equal to. So I'm going to put that as a closed circle. And then it is going off into positive infinity. Well, positive infinity is this way. So I shade everything on the number line. When I get to the end of the number line to show that that pattern is continuing, it's not just stopping at 5, I put an arrowhead to show that it's continuously off that way. You only have to put the arrowheads on here when you get the unbounded intervals. Next one says to graph or state what the interval describes from -infinity to 0. So at 0, so I'm going to put the number on the number line first. I know that it's not equal to because of the parentheses, so that means open circle. So at 0 I put an open circle. And this is saying then since 0 is the larger number, I'm going to -infinity, which is this way, that I'm going to shade everything that is less than 0. And then because the pattern is continued, because it's unbounded, I draw the arrowhead to show that exist that way. Alright, let's deal with absolute value. Remember that when you're dealing with absolute value is just a distance from 0. So if we were to put this on a number line, we basically want to know how far negative 5 is from 0. Well, if you take the time to graph that, here's 0. Here's negative 5. What is this distance? Well, this distance would have to be equal to 5. So what we say is that because distance can't be negative, the absolute value of a negative number is a positive number. So when I do a problem like this, the absolute value of 3 minus 9, I would figure out that 3 minus 9 is negative 6, and then, again, distance can't be negative, so it would be positive 6. If you want to think about this on a number line, you'd put 3 here, 4, 5, 6, 7, 8, 9. What is that distance that is between these two? Well, that's 6. When you do these, I'm not expecting you to make these graphs. Taking a look at our next one, I want you to evaluate this absolute value of x plus 4 over x plus 4 when you know that x is less than negative 4. And this is important to understand. What this is telling us is that x has to be negative. So if I think about this, if x has to be negative, I know that x is going to be some negative number, so I'll put some negative number in there and take the absolute value of that and divide it by x plus 4. What I know when I take the absolute value of a negative x, it's really going to be a positive x, and I forgot to put this one as negative because again x has to be a negative number. So when I take the absolute value of negative x, that's going to result in a positive answer. And then when I divide it by negative x plus 4, what's going to happen here is if I divide this out, I'm going to end up dividing this out and getting a negative 1 when I'm all done. So I can say that this reduces down to a negative 1. So sometimes that's a little bit confusing for students, so I recommend that you plug a number in that works. When x is less than negative 4, let's try negative 10. So if I plug a negative 10 in here, negative 10 plus 4 over negative 10 plus 4, in the numerator I'm going to get an absolute value of negative 6. In the denominator I'm going to get negative 6, and the absolute value of negative 6 is 6. Over negative 6 makes negative 1. So I think by showing you with a specific example, it works a lot easier to see that no matter what number you put in here for x, as long as it's less than negative 4, you're going to end up getting a negative 1 as your answer. So if you're struggling with these, my suggestion is to pick a number that works. In this case, negative 10 is an example of a number that works. You could do the same with negative 9, negative 8, negative 7, negative 100, as long as it's a number that's less than negative 4.